Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have a function y equals 3x over 1 minus x, and we have to sketch the graph of this function. We have to use intercepts, extrema, and asymptotes as sketching aid. So let's start with intercepts. How do we compute intercepts for a function? We set x equals 0 or y equals 0 and find the corresponding point. Notice if you have x equals 0, then the y will be equals to 0 in the numerator and 1 minus 0, so 1 in the denominator, which is also 0. This tells you that 0, 0 is a point on the graph of this function. And so 0 is also x and y intercepts. All right, let's go to the second part about extrema of this function. Are there any extrema? You know, to figure out maxima and minima, we take the derivative of the function and then see where the derivative is 0 or undefined. So here's the derivative of this function that you can use quotient rule to find the derivative. Notice that the numerator is 3, which means this will never be 0, and the denominator is 1 minus x squared, and the denominator will be 0 at x equals 1, so the derivative is undefined there, which is also a critical number. But the function itself is not defined at x equals 1, so there is no question of the function having an extrema, and so there is no extrema. All right, let's move on and see what we can figure out about asymptotes for the graph of this function. Let's start with finding vertical asymptote. So how do we compute vertical asymptote, if there is any? Look at the function itself. It's a rational function. And for a rational function, we know that where the denominator is 0, so x equals 1, is a possible vertical asymptote because the denominator is 0. So the function will be increasing or decreasing without bound at that point. Now, is it a vertical asymptote? Well, the numerator function is 3 times 1 at x equals 1, which is not 0. And therefore, yes, this is a vertical asymptote to the graph. So we know that we have a vertical asymptote, but let's also figure out how the function behaves around that point. In other words, I want to know what happens to the limit of this function as x is approaching to 1 from either side. So let's first figure out as x approaches to 1, say from the right hand side, how is the function behaving? We know it's a vertical asymptote. We know the function will either increase or decrease without bound. So we know that the answer to this limit will be either plus or minus infinity. Question is, which one is it? Okay, so notice x approaching to 1 from right hand side, which means x is taking values that are greater than 1. So you say you're plugging in a value that is bigger than 1. What happens to this expression? 1 minus something bigger than 1 will give you a negative value. What is happening in the numerator when you plug that value, something bigger than 1? Well, it's going to be positive. So this entire expression will give you a negative number, which means that the answer will be negative infinity. So the function will be decreasing without bound. Now what about the second limit? Limit as x approaching to 1 from left side, so minus. Let's consider it similarly. So x is picking values that are less than 1. So you're plugging in x equals something smaller than 1. So 1 minus that is positive. And notice the numerator will still be positive when x is taking values close to 1. And therefore, this expression will give you a positive number, which means the limit is positive infinity as x approaches 1 from left side. Okay. So that's how the function behaves around x equals 1, the vertical asymptote. Let's move on and consider if there are any horizontal asymptote. Now, how do we figure that? Notice that we have a rational function, polynomial over polynomial, and in that case, we look at the degree of the top and the bottom. So, the degree of 3x, that's the numerator polynomial, is, so what is the highest power of x? It's just 1, so degree is 1. And the denominator, 1 minus x, also the highest power of x is 1. So that is the degree of the denominator function as well. Now, since the two degrees are same, we know that y equals some constant will give us the horizontal asymptote. And how do we determine this constant? You come back here, look at the leading coefficient in the top and the bottom. So the leading coefficient is the coefficient attached to x, or the highest power of x. In this case, it is x. So the top, you have 3. The bottom, look, you have to look at the coefficient attached to the x, which is negative 1. So be careful, do not consider it's 3 over 1. It's 3 over negative 1, which means y equals negative 3 is a horizontal asymptote. Okay, so with all this information, let's go to a graph and try to sketch it after plotting all this various information down. First, we have the intercept, and we know that the origin is a point on the graph. Next, we know there is no extrema, so we don't have to worry about that. For asymptote, we have a vertical asymptote at x equals 1. So let's graph that. And we have a horizontal asymptote, y equals negative 3. That. So this is 1, and this is negative 3 here. Okay. Now let's see what's happening. For this side, we know that the function will pass through 0, 0. That's a point. Okay. We know from the second limit, as x is approaching to 1 from left, function is approaching to infinity. So function will be, approaching to infinity somewhere here. And this is a horizontal asymptote, so the function is approaching to negative 3. Okay, it is approaching to negative 3 like this. So we can join these two part to get a rough sketch of the function. Let's erase that. And you see that I don't have much space here, but as the function goes on and on, it will get closer and closer to the line negative 3. Okay, let's consider the right-hand part now. Now look at this first limit. As x is approaching to 1 from right-hand side, function is approaching to minus infinity. So it's going down here. And again, negative 3 is a horizontal asymptote, so the function will be going towards negative 3. So it will be pretty symmetric to this side. So we can join these two parts and let's erase this. So the graph of this function looks roughly like this right here. Thank you.